έχω ξεκινήσει.
So, Christos, you can take the floor and give us a welcoming speech.
Okay, thank you, Dimitris. Hello, everyone. On behalf of the entire CREAMS team, I would like to welcome you to this learning, teaching, and training activity of the CREAMS project that aims to educate policymakers on how they can adopt the CREAMS platform that has been developed throughout the past 3 years and which aims to support art students, educators, and university policymakers in order to trigger their creativity and provide open source tools for allowing them to create their own virtual exhibitions. Throughout the next 3 days, the CREAMS project consortium will present different aspects of the CREAMS platform, meaning suggested policies that can be adopted by higher educational institutions, guidelines for technicians that would like to install the technology that has been developed in the project, or even educational suggestions and directions on how these tools can be utilized in different academic contexts by academic teachers, for example, that will support their own educational goals. I'm very happy to welcome you again in this LTTA event, and I hope that all participants will gain from this experience, depending on their own needs and expectations, what they would like to know, to understand about our work. And we are, of course, all of us, and of course myself, are available not only during these days, but most importantly after the event, or even after the end of the project. We are available to give any support to any individual or organization that will show interest on how and when they can use our work. So thank you again very much, and I hope that we'll have a very good communication throughout the next days.
Thank you, Christos, for the welcoming. I'd like to thank all the participants for joining this 3 days event. It is an online event due to the war situation in Israel. As you already know, Senkar should be the organizer of this event. However, due to the war circumstances, Senkar asked the consortium to have another partner the lead of this event. So we accepted the challenge, and I hope that we will achieve to organize a successful 3-day learning, teaching, and training activity. Thank you, Christos, again for your participation. We can proceed to our agenda with the first talk. Let me share my screen. I hope that everybody can see my screen, the first slide of my presentation. Can you see it?
Yes.
Okay.
Yes.
Well, we are here for the last learning, teaching, and training activity of our project at the very last days of our project, which concludes its progress at the end of January. This is the third event in the series of learning, teaching, and training activities. after the first event that was organized again from the University of Patras, and the second one that was organized by Cyprus University of Technology. The title of this event is Training Policymakers on How to Adopt the Platform in Their Institutional Strategy. The actual aim of this event is to provide guidelines and directives to invited higher education institutes policymakers from participating in project countries, Greece, Germany, Israel, and Cyprus, about the instructional platform for creating and publishing arts-related academic work in virtual exhibitions. We are six partners in this project: University of Patras, Cyprus University of Technology, Cognitive UX, Aristotle University of Thessaloniki, Senkar Engineering Design Art College from Israel, and NTNU University from Norway. Some logistics for our project: the duration was 36 months. The start day was the 1st of February 2022, and the end day will be the 31st of January 2025. Now you can see the main functions of our project. CRIMS proposes four main functions. First of all, it aspires to engage stakeholders of European higher education institutes to elicit requirements related to the creation of virtual exhibitions for art students. One of the main goals is to design, develop, and evaluate a framework and open source tools for virtual exhibitions. Within CRIMS educational material for higher education stakeholders will be implemented and evaluated, along with learning, teaching, and training activities. Finally, all the produced material and tools will be disseminated through websites, social media, publications in journals, participation in conferences, organization of LTTAs, and multiplier events, taking special care for the sustainability of the project outcomes. In this context, CRIM's goals are fivefold. Till now, we have investigated existing solutions and established a first set of specifications which were used for the development of low-fidelity tools. Concerning the third aim, we performed the first formative evaluation using a class of 52 art students concerning the authoring part and 27 art students as simple visitors, 79 in total, along with a focus group of 3 specialists in virtual environments. The stakeholders' feedback from the first evaluation study used for the revision of conceptual design. The second version of conceptual design was the basis for the development of high-fidelity tools based on a user-centered design methodology. Now we have concluded the third cycle of CRIM's framework. The development of the final set of CRIM's tools was based on the findings of the second formative evaluation study, which was conducted with a class of 80 students. And also, now we are in the middle of the summative evaluation of the final tools using a class of 150 students in each of the participating higher education institutes. Concerning the fourth aim, we have created a repository with the sets of training webinars. We have conducted 3 sets of webinars, one in May 2023, the second set on May 2024, and the last set of webinars. The first one was conducted on November 2024, and the last one will be conducted tomorrow within the second day of LTTA, because the target audience is the same with LTTA, which is policymakers. Also, we have produced manuals about frameworks tools, namely the Digitizer, AR Exhibition App, VR Viewer and Editor in 5 languages, video tutorials, best practices guide, and course material. Concerning the 5th aim, we have published 5 conference and 2 journal papers, organized 2 multiplier events, and also we are going to organize the last one at the end of January. And also we have organized 3 LTTAs. Finally, we have created logo, website, and social media accounts where partners made regular updates. Here you can see CREAM's time schedule in the form of a Gantt chart. From February 2022 till November 2023, we have made progress in all PRs. Concerning PR1, in September 2022, we finalized needs validation and verification, specified readiness metrics of employing cutting-edge digital technologies, and the first version of CREAM's conceptual design. In September 2023, we built the revision of the first version of CREAM's conceptual design based on the first formative evaluation feedback and the discussions among partners. Concerning PR2, in September 2022, we finalized CREAM's architecture and structure design, and we developed low-fidelity CREAM's tools. In September 2023, we finalized the second high-fidelity version of CREAM's tools. Concerning PR3, in September 2022, the design of experimental methodology finalized, while in February 2023, the first formative user evaluation study completed. Also, the second formative evaluation was completed at the end of February 2024. Concerning PR4, on November 2023, we finalized the creation of the initial version of course material, best practices guide, and training material for instructors, along with the writing of manuals for ICT staff, instructors, and students. Also, till now, we have created integration guides for ICT specialists and software engineers. Concerning PR5, the first 2 webinars for instructors and students conducted in May 2023 with great success. Also, the second set of webinar for students were conducted on May 2024, and the last set of webinars conducted, the first one on November 2024, and the last one will be conducted tomorrow on January 2025. Additionally, 3 multiplier events organized from November 2022 till the end of 2025. The last one will be at the last day of January. As far as LTTAs are concerned, we have 3 LTTAs till now, and also every month we have regularly monthly meetings and so on. The last 6 months, we proceeded to the finalization of CREAM's tools in September 2024, along with the final set of conceptual design specifications. Also, during the last months of 2024, we finalized the course and training material of CREAM's project. Now, the summative evaluation of CREAM's project is in progress till the end of this month. Hopefully, we believe that at the end of our project, we will fulfill all project's goals. Here, you can see the 5 project results. The first one deals with the requirements verification and conceptual design of CREAM's framework. The second one is about tools design and implementation. in order to support digitization of physical artifacts and the creation of virtual exhibitions. The third one concerns the evaluation and the validation of the CRIMS framework. The last evaluation cycle is in progress till the end of this month. The fourth project result is about the development of course and training material about virtual exhibitions for art students, art teachers, and ICT specialists. And finally, we have the fifth project result, which is about the training aspect of the project and consists of three sets of webinars targeting all the stakeholders of this educational environment we aspire and successfully we have built. Here you can see some more details about LTTA we have conducted. The first one was conducted in the University of Patras. It was entitled Training Teachers on Platform Application and Methods of Creating and Publishing Diverse Digital Materials. This event was organized on May 2023 with great success, I can say. The second one was organized by CAT in Cyprus last September. The target audience was art students, and the aim of this event was the training of art students and the provision of guidelines and directives on how to use CRIMS method and tools. This event was very successful with the help of all the partners. Finally, the last LTTA should be organized in Israel by Senkar, but as I have already said, due to war circumstances, we decided as a consortium to have a virtual event organized by the University of Patras, and this is the first day of this event. Along with the LTTAs, we have conducted three sets of training webinars, which were led by Senkar. The first set on May 2023, the target audience was teachers, instructors of art schools. The second set was conducted on May 2024. The target audience was art students, and now we are within the third set. The first webinar was conducted on November 2024. The target audience was ICT specialists, and tomorrow we will have the sixth webinar, which targets policymakers as the main stakeholders of this event. Now, some information about dissemination and sustainability activities within our project. I have already said that we have organized two multiplier events, and another one will happen at the end of this January in Patras, in person. Also, the industrial partner, Cognitive, has made technology demonstrations in specific events. We have organized successfully a workshop within Euromed conference. We have prepared training material and webinars, promotional materials, website, our logo, and also Cognix has made all the appropriate actions in order to obtain open source software license for the developed tools in this project. Well, here you can see, let's say, the cold start of this project. We organized focus groups with experts, and using questionnaires and interviews, we have specified some basic, let's say, functions that an educational environment for virtual exhibitions should contain. First of all, we should provide tools for enabling artists to employ 3D digital exhibitions in order to reach new audiences. We should develop tools to give power to the artists to present contextual issues, ideas, and personal thoughts about their artworks in an original way. We should help them to create multimodal, in-depth descriptions of artworks in the form of art sketchbooks. And finally, the last function would be the adaptability of the modalities employed to the aesthetic and conceptual character of the artwork.
Ναι.
Now, till now, we produced some basic tools.
Βέβαια, ναι.
Excuse me, some microphone is open. Thanasis, I think.
Ναι.
Microphone is open.
Ναι.
Okay. Well, we have already developed a web-based platform with functionalities about art instructors, art students. For art students, we have developed an artwork management tool with which an artist, with which a student can manage all the digitized artworks and use them to build his exhibitions or her exhibitions. Also, we have a VR editor with which a student can construct an exhibition space and allocate the 2D or 3D artworks inside the space he or she built with our tools. There are services for teachers. A teacher can use two types of policies in order to assess students' work. The first approach concerns the student in the classic way. The professor assigns an exercise in the form of constructing a virtual exhibition. The student deals with this exercise, and when he or she finalizes his or her exhibition, then the teacher is informed about it and assess the outcome of this process. The other approach is the curatorial one, where the art instructor follows the art student during his or her voyage. The teacher helps student in various phases of the development of his virtual exhibition. For example, the student can ask the teacher about the digitized artworks or about the allocation of these artifacts inside the VR space or the outdoor space if we are talking about an AR outdoor exhibition. Besides the web-based platform, we provide another three tools, let's say, in the form of applications. We have a mobile application for the visitors in order to visit an outdoor AR exhibition in the outer space. This application can be used also for AR indoor exhibitions and AR in-home exhibitions. Also, we have a digitizer in order to help our student to digitize his or her artifacts. And finally, we have, let's say, a native mixed reality application with which a visitor can interact with a mixed reality exhibition. let's say, native application needs the usage of HoloLens 2 device in order to have such an experience. Furthermore, we have implemented certain security functionalities like role-based access control models, blockchains. We have implemented some interactive features such as pop-up widgets with text, multimedia content, and multimodal annotations. And we have incorporated certain personalization capabilities. Later on, you will hear more about these functionalities. Furthermore, we provide administration functionalities for young artists, and all these are accompanied with a knowledge repository where everybody can find tutorials, videos that explain the usage of the developed tools, or even scenarios for developing course material. Here you can see the followed methodology throughout the project workflow. To specify the CRIMS framework user requirements, we first studied literature and relevant implemented commercial systems regarding system functionality, the involved users, and the supported content. Then our findings were triangulated concerning system designs, implemented applications, and best practices with the help of a group of art teachers. Thus, we specified the first set of design principles. Following, we created a series of mock-ups aiming at visualizing services and functionalities based on our findings. To evaluate the basic usage scenario of the CRIMS framework concerning the insights into the needs, preferences, and priorities of envisaged stakeholders, namely our students, teachers, and visitors, we designed and implemented 3 separate focus groups. The next activity is related to the definition of quantitative and qualitative metrics that reflect the readiness higher education institutes have with regards to the aspect of employing cutting-edge digital technologies to manage results of arts-led academic work in ways that highlight the sophistications of the artworks and contextual material concerned. Results from the needs analysis and verification and the derived readiness metrics constituting the basis for setting the specifications of the framework. Those specifications in the form of conceptual design used for the design of CRIMS structure and architecture that led to the development of CRIMS low fidelity tools. Next, we designed a concrete evaluation methodology in order to verify and validate the implemented tools. This knowledge used in the first formative evaluation, which results was our input for the revision of the conceptual design and the development of the second version of CRIMS tools, the high fidelity ones. Complementary, a first set of course and training material was created and used in the 2 training webinars conducted in May 2023. We completed the second formative evaluation, emphasizing on usability and user acceptance of the implemented tools so far. Also, we conducted the second set of webinars. And finally, in September 2024, we produced the last set of specifications for our conceptual design, in which the final set of CRIMS tools was based. Also, we have produced 2 more sets of course and training material. Now we are in the middle of the summative evaluation of all this work. Actually, we used 3 development and evaluation cycles in order to reach the final outcome of this project. Here you can see some slides about the conceptual design outcomes. Here you can see the first version of the conceptual design. Clearly, you can see the basic building blocks of our frameworks. You use three databases for artworks, exhibitions, users. Also, we have a backend system. We have tools about art students in order to manage artworks and exhibitions. We design teacher services about exhibition initiation and assessment, security management, and basic core system functionalities like 3D rendering. At the front end, we designed augmented reality exhibitions application, social media and dissemination application, artwork digitizer application, along with mixed reality and virtual reality exhibitions applications. After the first formative evaluation, we reached at the second version of our conceptual design. Now we have incorporated into the databases the knowledge repository. Also, we refined the back end of our system. Clearly, you can see that teacher services are divided into the two approaches I have already mentioned, the classical one and the curatorial approach. Artist services appear here for the first time, along with some security management concerns, like the usage of blockchain. Now we we blend the three AR exhibition applications we have designed at the first conceptual design into a unified application with, let's say, three functionalities. One functionality is about outdoor exhibitions, another one about indoor exhibition, and the last one about in-home exhibition. Also, you can see the target user groups. Now we have incorporated, besides artists, teachers, visitors, and students, the group of administrators. Finally, here you can see the final set of conceptual design specifications we have reached. We don't have many changes from between this version and the previous one. Actually, we mainly refined the services which implement all these functionalities. Finally, we reached the development of a framework which provides an art student workshop with VR and AR editors for building virtual exhibitions, along with tools for portfolio management. We provide a VR exhibitions viewer for the visitors, along with an AR exhibitions application for outdoor, indoor, and in-home exhibitions. Also, we have developed a native application in HoloLens 2, with which a visitor can experience a mixed reality exhibition. As far as the digitizer application is concerned, we provide a 2D artwork digitizer functionality, and also we permit to all the students and young artists to upload 3D artifacts using specific access points in the web-based platform. We have a concrete set of teacher services and art services, along with personalization services and communication services. As far as the evaluation is concerned, after the implementation of, after the definition of a certain experimental methodology scheme, we proceeded to two formative user evaluation studies about the first two versions of CRIMS tools. And now we are in progress for the final summative user evaluation of the final version of CRIMS tools. As far as the course and training material is concerned, we have produced material concerning instructors and students, along with guides of best practices and training material in the form of text and videos for instructors and ICT specialists, along with specific manuals for software engineers. And we tried to produce all this material in all the 5 native languages of the partners of this consortium, namely Greek, English, German, Hebrew, and Norwegian. We have conducted 3 sets of training webinars on conceptual aspects of virtual reality for instructors, students, ICT engineers, and policymakers. We organized 3 multiplier events. The last one will be organized at the last day of January 2025. And also we have conducted 3 LTTA events. As far as the dissemination is concerned, Cognitive UX produced a logo for our project and also constructed the website and manages community forum and social media accounts. We organized 1 workshop in a well-known digital humanities conference, Euromed 2022, and we have produced till now 2 journal and 5 conference papers. Here you can see the 2 journal papers. They were published by accredited journals, the Journal of Cultural Heritage and the Journal of Digital Applications in Archaeology and Cultural Heritage. And also here you can see 5 conference papers. Recently, during the summer, we took the best demo award in a well-known conference, UMAP, an ACM conference in Sardinia. So that's all for our project. I tried to give you a brief summary of all the things that have happened within the 3 years of this interesting journey, let me say. Thank you very much. Is there any question, any point any of our participants wants to raise in order to have a discussion? We have 15 minutes till the coffee break. I'd like to say hello to all the participants that joined us within my speech. Before me, the scientific coordinator of this project, Professor Fidas, welcomed all the participants and the event. Well, the floor is yours if you want to discuss something in this initial, let's say, point of our event. Well, okay, then we can proceed to our coffee break and come back after half an hour at 3:30. Thank you very much. The agenda of the event. After that, we are going to proceed to a summary of the basic project results, starting from the design and the verification, and going to the development of tools, evaluation, the building of course and training material, and the conducted webinar. Let me share my screen. I hope that you can see the first slide in my presentation. I'm going to talk briefly about the 3 days event agenda. As I have already told, the title of this event is Training Policymakers on How to Adopt the Platform in their institutional strategy. Now you can see some logistics about the events. About the event, the number of participants should be 19, and they should come from all the partners. Also, I have already talked about the main goal of this event, to provide guidelines and directives to invited higher education institutes, policymakers from participating in project countries about the instructional platform for creating and publishing arts-related academic work in virtual exhibitions. Through participation in this event, we wish to educate and bring awareness to higher education institutes, policymakers about the necessity of incorporating such technological means and methods as part of an organization and educational online promotion. By disseminating the platform's usefulness and ease to use, we aim to the potential of using the platform showcased to foster academic research in the arts through online exhibitions with state-of-the-art technologies. Thus, the event participants will gain the confidence to incorporate the utilization of such solutions in given higher education institutes policy. Now, within the scope and several objectives will be including in the event's agenda. First of all, the first day, we have an introduction to the project. We have already explained the basic purpose of this meeting. Now we will explain our agenda to assure full transparency of the event workflow for the participants. All planned activities and main points also of the agenda will be presented. We will talk about training presentations. During this part of the event, participants will be presented with essential information regarding the importance, application, and potential of exhibiting digitalized artworks with the use of virtual reality. This is the purpose of the presentation of the 5 project outcomes. Now, as far as concerns the second day, we will start with a short summary of the outcomes and highlights of the previous day, followed by a brief introduction to the activities planned for the second day. Mainly, we have training presentations. The major and essential part of the event will be a presentation of training materials and manuals related to the platform functionalities and the possibilities they offer, as well as its tested application by participants of the first 2 LTTAs. Finally, the third day, the beginning of the day of the third day will be dedicated to summarizing the outcomes and highlights of the previous day, followed by a brief introduction to the activities planned for the third day. The main part of the meeting will be dedicating to exchanging experiences, insights, and observations regarding the training materials and manuals of the platform utilities and capabilities. And finally, at the event closing, all participants will be asked to join a roundtable discussion about presented training materials and to share their insights and observations about the project application. Well, what we anticipate as outcome of this event is threefold. First of all, gaining new knowledge and insights regarding necessities of adapting the form online content to the preferences of the envisaged audience. Secondly, receiving guidelines and best practices for system adaptation in the policy of its higher education institute in order to utilize such solutions. And finally, connection and networking with colleagues to support knowledge exchange and best practices to incorporate such solutions. Well, this is, let's say, a short explanation of this 3-day events agenda. If there is any question, I will be happy to answer. Otherwise, we can proceed to the next topic that concerns the basic outcomes and findings of this project. Is there any question? Okay, then can proceed to the next topic that concerns the outcomes and main findings of all project results. We start with the first three project results. Project result 1, 2, and 3. They concern the design, development, and the evaluation of the project. Well, maybe you are bored of me, but on behalf of University of Patra's team, I will present the first project result, which is about the requirements verification and conceptual design of the framework for virtual exhibition. Let me share my screen. Okay, I hope that everybody can see the first slide of my presentation now, which is about the main findings of project result 1. As you can see from the title, this project result concerns mainly the design phase of the project. Well, the role of project result 1 is to describe the research and analysis of current and existing solutions for presenting academic work and the triangulation of these findings with participating stakeholders' expertise to drive the implementation of the framework. The goal of this project result is to derive knowledge on intrinsic requirements with respect to the employment of virtual reality platforms for art exhibitions in higher education institutes. This new knowledge will be used for the design and development of the framework. To the best of our knowledge, there is no conceptual framework that addressed the need to scaffold art student skills in making optimal use of virtual exhibitions within the higher education domain, higher education institutes. Key points of innovation are first, the needs analysis, verification, and validation through the planned case studies that generated new knowledge and provided practical insights on the requirements of arts-related higher education institutes in Europe. And secondly, the conceptual framework for the development of a multifaceted platform through which art students will gain valuable knowledge and skills. The conceptual framework is being analyzed in detail for its development cycle. Well, to specify the CRIMS framework user requirements, we first studied the literature and the relevant implemented commercial systems regarding system functionality, the involved users, and the supported content. Then our findings were triangulated concerning system designs, implemented applications, and best practices with the help of a group of art teachers. Following, we created a series of mockups aiming to visualize any services and functionality that were based on our findings. Based on literature reviews and mockups, we performed focus groups. To evaluate the basic usage scenario of the CRIMS framework concerning the insights into the needs, preferences, and priorities of envisaged stakeholders, namely art students, art teachers, and visitors, we designed and implemented 3 separate focus groups. We involved 9 participants and 2 facilitators on average. The discussion sessions lasted about 1 hour. We followed the suggested number of participants, 8 to 12, and the duration of sessions to ensure validity due to the bibliography. Likewise, we adopted an adequate number of about 8 civil questions. We have introduced the basic usage scenario and shown several interface screens to familiarize participants with the project's aims, developing characteristics and potential. Therefore, we delivered presentations at the beginning of sessions lasting between 10 to 15 minutes, leaving 45 minutes of actual discussion and questions. Hence, we opted for about 9 participants to allow for views to be expressed by as many and for as long as possible within the above time restrictions. We introduced the CRIMS framework, developing tools, applications, and interfaces, emphasizing that it is not a finished product to be assessed as such. Each focus group was presented as an opportunity for discussion and elaboration on what possible forms it could take in order to better respond to their own needs and preferences. The purpose of the study was clearly presented in detailed text within the consent form sent. The three focus groups were led, in each case, by one of the three schools of fine arts involved in CRIMS: Norwegian University of Science and Technology, Aristotle University of Thessaloniki, and Schenker College of Engineering, Design and Art, with the presence of facilitators from the other two. Focus group participants were invited by or affiliated with these institutions, and we aim to have an equal share of participants from each school. Another key activity in Project Result 1 relates to defining quantitative and qualitative metrics that will reflect the readiness of higher education institutes to employ ICT platforms. Based on a state-of-the-art literature analysis, identification and definition of quantitative, quantitative and qualitative metrics used for reflecting the level of readiness higher education institutes have with regards to the aspect of employing cutting-edge digital technologies to manage results of arts-led academic work in ways that highlight the sophistication of the artworks and contextual material concerned. Results from the needs analysis and verification and derived readiness metrics constituted the basis for setting the specifications of the framework, which drove the design and development of the low-fidelity version of CRIMS platform, related technologies and methods. Low-fidelity version of CRIMS platform evaluated during the first formative evaluation. Based on the results of the first formative evaluation and discussions with stakeholders from higher education institutes, external advisory board members, and among the consortium members, we revised the specifications of the CRIMS framework and proceeded to the design and development of the high-fidelity version of CRIMS platform, related technologies and methods. The second formative evaluation was conducted in order to assess the usability and effectiveness of the CRIMS virtual reality editor and related applications, gathering feedback from various stakeholders, such as art students, art teachers, and ICT specialists, and to identify areas for improvement in the user interface, functionality, and overall user experience of the applications. In addition to the formative evaluation, there have also been extensive discussions within the consortium and with stakeholders regarding the technologies used. These two stages led to the final conceptual design of the CRIMS framework. That final conceptual design was followed for the final version of CRIMS. Here you can see some of the materials we used in the research methodology for the CRIMS project. Specifically focusing on the focus groups, these questionnaires were used for gathering data from various stakeholders involved in virtual art exhibitions. So our two materials were questionnaires and interviews with focus groups. Now you can see the workflow for needs validation and verification. As first step, we mapped existing approaches, requirements and special characteristics of the material to be communicating through virtual exhibitions. And the second step was the verification of findings of the needs analysis through semi-structured interviews with stakeholders of the participating higher education institutes. We have also revised conceptual design based on the formative user evaluation study that tests the effectiveness from the perspective of system integrity, aptitude for exhibiting artistic material, and art education. And of course, discussions among consortium members and discussions with stakeholders from higher education institutes. Actually, we revised two times our conceptual design, so we produced three versions till the final conceptual design. Now, the first thing we've done was to study the literature. First of all, we dealt with the digitization of 2D and 3D objects. For this, it was necessary to carry out a literature review and find out all the technologies available at the moment. As you can see from the table, there are various measurement methods that could be applied to 2D, 3D geometric recording and range from standard simple topometric methods for partial or uncontrolled surveys to complex methods using modern photometric and surveying techniques for controlled surveys. The basic considerations in the digitization field were all the mentioned and reviewed applications offer a functional and user-friendly experience and are functional and compatible on the iOS platform with the exception of QLON, which is available in both platforms. During the testing and review, we had high-resolution results with millimeter accuracy and real-time scanning. The most accurate results yielded came from the combination of LiDAR technology and true-depth cameras provided by Apple in the new state-of-the-art cameras on iPhone 12 series or later. Now, concerning hardware, there are no requirements regarding special graphic card or limitations on RAM. An important element is the metadata collected by the system during use, import, and export. The reviewed applications collect exactly the same metadata, which apply to the precise location of the device in all phases of the application usage. Also, each application has a different approach in terms of extraction of data after the scanning is finished. Some export 3D models, others export 3D mesh, while in a single case the results yielded are in CAD format. In the area of intellectual property rights, the applications point out that the use of the software and their functions is done exclusively through their platform. However, after a user completes the scanning of an object, the application does not prohibit the exportation, and the user now has exclusive rights on that result. All the reviewed applications are open source, but none of them can be embedded in a foreign system application. The next topic we studied through our literature review concerns XR technologies. We reviewed actually the current state of extended reality technologies used in virtual exhibitions and their potential applications, investigating how these technologies can enhance the presentation and engagement of art. We demonstrated basic technologies for XR. However, we should state that this categorization is not exhaustive. You can see this categorization in the figure in this slide. The development of related to XR technologies is growing day to day. Based on that, we have published a journal paper at the Digital Applications in Archaeology and Cultural Heritage journal. Now, personalization is another dimension of our project. Actually, there are three dimensions for information systems personalization in the bibliography. What? All this try to answer three questions. What question? Concerns content, the information, user interface, meaning the information presentation, to functionality, what users can do, and the channel, the media used for information delivery. The second question concerns to whom, meaning that individuals or categories of individuals have specific characteristics. And finally, we should answer the question, who does it? Answering it, we show that can be done automatically by the system, or we can have explicit personalization when the user provides information or guidance. There are many classifications for personalization systems based on the data they utilize, the learning paradigm used, the location, and the process of the interaction with the user. The data needed to implement personalization in information system may vary depending on the chosen personalization model. That is followed. We have demographic data, behavioral data, and contextual data. Here you can see some key points from the literature review concerning personalization techniques. Content-based filtering, we can say that is the most basic method of all recommender systems. Its prediction is based on the types of items a particular user selected in the past. It clusters users based on their past recorded preferences and makes future recommendations based on their classification. While content-based filtering makes suggestions based on the user's preferences or specific features of an item, the collaborative filtering system does not need the features of the item. It relies on how users responded to the same items without relating to the actual features of the item, and it predicts user preferences based on other user preferences. For clustering, the system needs to calculate the similarity between users or items. Data mining, association, and sequence rule-based approaches are used to predict and analyze user behavior. Association rules are a basis for machine learning, namely creating artificial intelligence where the program can become more efficient without being explicitly programmed. The hybrid technique is a recommender system where the score of a recommended item is calculated from the results of multiple recommendation techniques. And also we have characterized all these hybrid techniques. Now, the next dimension we explored was about extended reality systems for virtual exhibitions. Actually, we have published two journals based on this literature review. We studied all the commercial, let's say, platforms that use extended reality tools for virtual exhibitions, and we categorized them with criteria that you can see in the tables. Also, we have produced a scheme studying devices, features, and provide software. Now, next, we discussed the process of filtering state-of-the-art findings through expert opinions, emphasizing the importance of validating the needs analysis conducted with the previous steps by engaging with stakeholders, including art students, lecturers, and system developers. The aim was to gather insights into existing practices, challenges, and the application of current technologies, specifically in the context of virtual reality and mixed reality for art exhibitions. This verification process helped to identify the core features and functionalities needed for a successful virtual exhibition platform. Furthermore, presenting and communicating artwork is a crucial part of art education, underlying the need for effective tools that support these processes. The findings from the expert opinions contributed to shaping the conceptual framework for the CRIMS project, ensuring it meets the requirements of its intended users. We ended up with a set of basic requirements. You can see in this slide those requirements. If you permit me, I can briefly say that the platform should contain tools that empower artists to present contextual issues, enable artists to employ 3D digital exhibitions, facilitate the creation of multimodal in-depth descriptions of selected artworks in the form of art sketchbooks, promote the adaptability of the modalities employed to the aesthetic and conceptual character of the artworks, and so on. Now, the next step was to create mockups. Several mockups were created to visualize the user context of a system that deals with digital exhibitions. These mockup screens were based on the filtered existing approaches, requirements, and special characteristics of the material to be communicated through virtual exhibitions. In the next slide, I tried to briefly present them, placed in several scenarios dedicated to the stakeholders of the system. I'm starting with a basic scenario about an art teacher that initiates an exhibition. This scenario describes the process by which an art teacher logs into the system and views a dashboard containing unpublished exhibitions. The teacher can initiate a new exhibition by filling in relevant details such as title, duration, and student participation. The teacher also has the option to select students for the exhibition, which can either be saved as temporarily stored or published for accepting artwork. A second scenario concerns the assessment of an exhibition by an art teacher. In this scenario, an art teacher assesses the exhibitions assigned to her or his students. The teacher assesses a menu containing all exhibition assignments, which includes information such as start date, end date, and status. The assessment process involves the teacher reviewing participating students' works, providing feedback, and ultimately publishing the exhibition. Here you can see another scenario when a student uses the digitizer app. In this scenario, a student needs to add artworks to the system, particularly for those that are tangible and not digital. The student activates an app and logs into the system. After logging in, they can attach titles or descriptions, upload existing files, or take pictures, videos of their artworks. The app guides the user through the process of creating a 3D model by taking multiple photographs from different angles, which will be uploaded to the system and stored in the student's repository. Another scenario concerns the creation of an exhibition by a student. Here, the process of a student creating exhibitions is described. After logging in, the student views a dashboard with information about assigned exhibitions and uploaded artworks. The student can create both indoor and outdoor exhibitions, manage artworks, and set up exhibition spaces. Here you can see how an art student sets an exhibition space. When the student ends with uploading, managing her or his artworks, she or he should click on the menu My Exhibitions, where she or he can access the page that lists all her or his exhibitions that are finished and available to the public, as well as the assignments to create a new exhibition. In the page, there is a section called My Assignments. The student has the option to create both an indoor and an outdoor exhibition for the assignment. Also, I have some more scenarios. I'd like to go on. I think that an interesting scenario is about the viewing of a 3D exhibition by a visitor. The visitor selecting a specific exhibit, he is able to see some basic information about it, like the title and description. Or if she or he wishes to see detailed information in the form of an art sketchbook. The basic information appears as a caption in the exhibit and the details as digital windows around the exhibit. I think that the next speaker will talk more about that. And also I have some other scenarios concerning the AR. Now, as I have already told, we developed some focus groups with art student teachers and art exhibition visitors. And we ask specific questions to them to gather some results. Here you can see a grouping of the focus groups results. These results provide insights about how the stakeholders experience and what they expect from virtual exhibitions within a framework like CRIMS. The participants emphasize the need to have the ability to manipulate the space of the virtual reality exhibition. Another point they mention concerns the importance given to the inclusion of visitors' comments and provisions for interaction amongst them as well as with the artists. And finally, they have interest about selling art through a digital platform. They asked a lot about NFTs and how we can include them in our problematic. Well, now about readiness metrics of employing cutting-edge digital technologies. To construct the metrics, we identified, based on the literature review, a list of criteria that are considered critical and essential to the construction of a digital exhibition, making and learning platform. These operators are organized according to four axes or levels, if you will, that together form the fundamental of a successful virtual exhibition platform. The axis and its extremities are visualized in the figure. The different levels are situated between the indicated extremities or liminal spaces. These extremities are not to be understood as metrically or conceptually opposed, but rather in context with the semantic operators, indicate an importance measure for the applicability of the levels in the platform. And after all this work, we reached the first version of conceptual design. Here you can see this version. I have already explained it at my previous speech, so I will go on. Here you can see some core services we had incorporated in the first version. There are core services like authentication and registration, through which the system can support authentication with login password service. Also, as far as the authorization is concerned, the system supports three types of users, adopting a role-based access control model. Each type of user has different permissions on data. Administration is based on role assignment as system setup. Also, there are geolocation services on both desktop and mobile settings. On the desktop environment, they are used by the students to create an outdoor exhibition, and on a mobile setting by visitors to locate exhibitions and artworks. There are some personalization services with which all users can get personalized recommendations. And of course, analytics. The system creates log files that are used for the personalization services. There are viewing and searching capabilities and copyright protection functionalities. For the specification of personalization services in the CRIMS framework, we triangulating the findings of the literature review with the help of a group of experts, art teachers. For further filtering, we used interview data acquired by art students. We ended up in a set of requirements related to personalization services. You can see them in this. Now, here you can see a personalization scenario. In order to illustrate the system functionality regarding personalization, we created several scenarios. Here we present one of them. In this scenario, the visitor uses HoloLens 2 to view a physical exhibition. It exploits interactions like hand and eye tracking and system gestures. Personalization is memory-based. The system is set to provide the first recommendations after the user completes the exploration of the first artwork to obtain some behavioral data. As soon as the visitor stands in front of an artwork, relevant information will appear next to it. This information may be images, text, audio, or 3D objects. An informative object that may be contained in an artwork is the artist's sketchbook, which can be presented as a virtual book. While the system gathers more and more behavioral data, the information that is likely to be interested in the visitor will gain in size and get bigger to draw her or his attention. The visitor may use the head gaze cursor or a gesture to select, change the size, rotate, or change place of any virtual object. In case he or he points her or his eyes on the artwork, he or she can initiate a video overlaying it that provides the illusion that the artwork came to life. Also, an important piece of information is the sketchbook. The visitor may choose to read its hologram and so on. Now, here you can see the teaching staff services we designed at the first version of conceptual design. We talk about exhibition initiation, with which teachers can start a new exhibition. And during this process, they only choose the exhibition targeting and select the students. And another service, the exhibition assessment, with which instructors can initiate an exhibition, setting a number of co-advisors, and all of them can assess then the exhibitions And finally, the advisor can reach the conclusion, putting an overall assignment. Now, as far as concerns student services, we have a service about artwork management, artwork digitization, and exhibition creation and management. Now you can see some preliminary visitor services, rating, and social media sharing. After the first version of conceptual design, we revised all this work based on the first formative evaluation feedback we had. What about that? A user experience evaluation was performed regarding the implemented system functionalities and those that are envisioned and other formulation in accordance with the requirements of the main stakeholders. The aim of the presented results is to reach conclusions and establish specific directions for developing interactive virtual exhibition tools in art-related education environments. Therefore, the interactivity provisions are a focal point within our assessment procedure, specifically in discussion focus groups comprised primarily of art students, given that virtual art exhibitions are created and their affordances tested at this stage. In this work, you can see, in this slide, you can see the basic key points we reached concerning interactivity provisions, ease of use, and the aesthetic aspect. Now, here you can see a summary of the first formative evaluation results, what we needed to do in order to revise accordingly the first version of our conceptual design. And in addition to the formative evaluation, there have also been extensive discussions within the consortium and with stakeholders regarding the building blocks of the platform. They indicated a number of points that should change. First of all, the administration should be a standalone functionality within the backend. Secondly, a separate database is needed to host the data from the webinars. Third, the initial plan included the implementation of 3 AR application, but the consortium decided to proceed with 1 AR application, including all the functionalities. And finally, the stakeholders from the higher education institutes suggested that we should host 2 more approaches regarding the exhibition creation. One that is called the curatorial approach and belongs to the same category as the already implemented teacher-instructor approach, and one that is called the artist approach and belongs to a new category of services dedicated to artists. Here you can see the basic a diagram with the basic ideas we had about the curatorial approach. According to this slide, teacher define the steps that are needed for the curatorial approach. Students gathering their artworks, examining the artworks, arranging the content in groups, providing a description to each group, receiving feedback from the instructor, final assessment, chat communications, and so on. All these steps are the basic steps in order to realize what we say is a curatorial approach. According to this work, we proceeded to the revision, the first revision of our conceptual design, and here you can see, let's say, a new conceptual design diagram, a more refined one, comparing to the first version. Here you can see that we have 4 databases. Also, we have the backend and the front end, security management services, teacher services, art services, and so on. Also, we have included more user groups, and also we refined accordingly all the services. Some of the services are included here as the first version. However, we have enhanced them with more functionalities. A new service is the 3D rendering service, according to which the user can create 3D models of any artwork. The needed sequence of images can be created and uploaded to the system with the use of the physical artwork digitizer. Also, we have now two teacher services, teacher as an instructor and the curatorial approach, and some more student services. Here you can see visitor services and artist services along with the administration one. Now, after that, we, let's say, evaluated the new version of our software, the high fidelity version, which was based on the second version of conceptual design. And the second formative evaluation produced specific feedback in order to proceed to the final revision. During the second formative evaluation, we assessed the usability and effectiveness of the CRIMS VR editor and related applications and identified areas for improvement in the user interface, functionality, and overall user experience of the application. Now we gathered free feedback from more categories of stakeholders, except students, teachers, and visitors. We have ICT specialists. Also, you can see here that most of them evaluated most of the modules of our framework. Some issues that indicated by our students, mainly they indicated issues related to realism, navigation, interface, connectivity, and support of guidance. Let's say realism issues. They need to see better textures in three-dimensional space to look more realistic and avoid breaking through walls. Also, they want to ensure perspectives that are from a human height. As far as it concerns the navigation issues, there is a need for simplification in moving between options and better controls for selecting and adjusting elements. For interactivity issues, they mentioned that there is a need about more flexibility in using the whole room and not just the walls or artwork. Some points mentioned by students. Now, some points mentioned by our teachers within the second formative evaluation concerned usability and navigability, visuals and aesthetics, and functionality. Visitors raised issues about user experience and supportive material, and ICT specialists raised issues about help and guidance services, flexibility in use, and navigation and usability issues. Now, we concentrated all this feedback and we specified specific areas for improvement of the framework and the conceptual design, of course. You can see here that we needed to perform improvements towards the user interface, navigation, realism and visual appeal, support and guidance, interactivity, technical stability, and feedback mechanism. But more from them will be discussed by our Panagiotis Dafiotis at his presentation. Now, some outcomes concerning consortium and stakeholders discussions regarding the use technologies. All these discussions were complementary to the formative evaluation. An outcome of those discussions was that the CRIMS platform should utilize a user modeling, personalization, and recommendation engine, aiming to recommend best fit exhibitions and or artworks based on the user's interests. With regards to art terms, it is suggested to adopt the model by state art terms and special context terms. So we proceeded to the final version of conceptual design. You can see in this slide. Actually, we made more refinement to the second version. And also, we have added specific services Again, we have the basic system services, which span from core services, art student, teacher, visitor, artist, and administration services. Here you can see the basic art student services. We have a service about virtual reality exhibition space creation, artwork digitization, exhibition creation, management, and artwork management. Here are the core services that can be used by all the users. Teacher services, visitor services, artist services, and administration services. We have included here the blockchain functionality and guides in learning material management along with knowledge repository management. Well, that's all about the outcome of project result 1. I tried to give you briefly a whole idea of the work we have done in order to produce, let's say, a conceptual design that reaches the end user needs. We have started from scratch, as you have heard here, and I think that we reached a level which is acceptable in order to give feedback for the implementation of an efficient framework, like the one we have developed here. Thank you very much for your attendance. If there is any question. Okay, then we can proceed to the project result 2 outcomes. Dr. Belk can take the floor and shares his interesting presentation with us. Thank you.
Hello, everyone. So my name is Marius Belk from Cognitive UX GmbH. And in this session, I will present you the main outcomes of project result 2, which had to do with the design and development of the main technologies and platform of CRIMS. So I will start with an overview of PR2, the main objectives, tasks, and the leaders, the contributions from our consortium. And then I will share the conceptual design, architectural design, and make an overview of the final version of all the tools and technologies. So project result 2, with regards to the main objective set in the technical annex in the proposal, the aim was to design and implement a set of tools supporting the digitization of physical artifacts and creation of virtual exhibitions. Cognitive UX has been the leader of this project result, with all the other partners of the consortium contributing in this project result. The University of Patras, the Cyprus University of Technology, the Aristotle University of Thessaloniki, Shankar Engineering, Design and Art, and NTNU. The project's objectives was to design and develop an integrated platform for higher education institution scholars, with the aim to create, disseminate, and promote digitally the research results, incorporating new technologies and ICT trends. And as Professor Kougopoulos already showed, based on the outcome of PR1, the conceptual design, the information was fed into the project result 2 package, in which we support an innovative workflow consisting first of process of digitizing a physical artifact and uploading this into the CRIMS platform through a mobile application and through online means, assigning then these, enabling students and artists to assign the digitized artifacts to a virtual exhibition and personalize narratives to various technological means. So based on this, we have implemented a set of applications to support different interaction contexts. One that is virtual reality exhibitions, augmented reality exhibitions, and mixed reality exhibitions. More specifically, the key objectives of Project Result 2 was to first design a software architecture by realizing the conceptual framework that was provided to us by the team from Project Result 1 for the conceptual design. Objective B relates to the actual development, implementation of the technological tools and methods in order to be able to streamline the digitization and management organization of the various material and data within the exhibitions. Objective C, implement metrics and indicators for aspects like user acceptability, ease of use, providing adequate sense of presence of virtual exhibition viewers, and functionality at the user interface layer. And finally, Objective D was to implement basically all these technologies as open source, aiming to provide support this pipeline of digitization and managing virtual reality exhibitions. The tasks are set in the technical annex. First, in the beginning of the project, we focused on the architectural design and structural design, which was co-led by Cognitive UX and UX of Patras. Task 2.2 relates to the digitization of physical artifacts and the personalization of virtual exhibitions based on customized narratives, a task led by the Cyprus University of Technology. And task 2.3 relates to the main development, integration, and the privacy preservation of the various developed components. We followed a user-centered design approach throughout the 3-year project, which resulted in releasing 3 main versions, starting with a low fidelity, a higher fidelity version. Now we have the final version. The last development cycle ended in September 24. And this has been the latest version, the final version that will be released, has been used in the final summative evaluation, which will be presented later on in this session of PR3. So this was a quick overview of PR2, and I will continue presenting the main architectural design. This is a quick snapshot of the latest version of the conceptual design as shown earlier. Based on this conceptual design, we took several decisions related to the technology, the languages that will be used, the platform, and accordingly, we ended up in the following architectural design. So we followed a client-server architecture. And the main reason was that we had several client-side applications, native ones like Microsoft HoloLens native apps, Android applications. The platform was a web-based application. We have the Digitizer application, which is another Android app. So we wanted to provide an architecture that splits nicely the client and the server, in the sense that at the server side, we have the main data, the user management, data management, and we expose all the relevant functionality through an application programming interface so that each of these clients can access and call all of these functions and methods to access the data related to the CRIMS platform. As you can see on the left side, we have the CRIMS client applications. We start with a Digitizer mobile app. It is an Android app, which is, I would say, one of the first steps someone would use to digitize a physical artifact. The data is uploaded through to the artist-centered content management system, which is a web-based solution based on HTML5 and all the state-of-the-art front-end technologies for web, which includes instructor services, access to all the various tools for managing the exhibitions, assigning digital artworks to the exhibitions, either this is virtual, augmented, or mixed reality. So this is a main tool and workshop enabling students to manage their digitized artworks and their exhibitions. And from then on, we also have 3 different client applications for visitors, basically. The virtual exhibition, which is again via a web-based virtual reality component. We have the augmented reality mobile app in Android, and a native mixed reality native app for Microsoft HoloLens. So all these client-side applications communicate with all the relevant endpoints through an API that we have built from scratch, which provides access to the data and the various functionality of the CRIMS platform. Some more technical details with regards to the backend architecture. As I mentioned, we follow a server-side, a client-server architecture, in which at the server side we have a web-based application programming interface. For doing so, for implementing this, we have built the whole framework on Django REST, the REST framework API, which is basically a toolkit for building web APIs. And we have some other technologies for load balancing, building a technology a component that can act as a web server. Specifically, this is called Nginx. We have GUnicorn, which is an application server to be able to provide and include application logic at the server-side components. And we also have some other components like Celery for asynchronous task queues based on distributed message passing. And this is mainly used for a bit more heavy tasks in which someone might want to use asynchronous tasks so that you don't have an end user waiting until the request has been processed. We also use RabbitMQ, which is a message broker, so that the components within the framework, within the platform, can communicate gracefully. And for a database, we use a relational database called PostgreSQL, which is common SQL database used when someone uses Django REST frameworks. So all these technologies has been carefully chosen in the beginning so that there are no major compatibility issues. And with regards to compatibility, we have also put everything under a Docker container for support mobility, so that someone can take this container, the Docker container, and integrate it in their system, in their operating system. And now, with regards to the final tools, we have different tools and technologies with various partners responsible. So Cognitive UX was responsible for building the artist-centered content management system, the web-based system, build the main platform, also responsible for the integration of the various technologies. We have also implemented the web-based virtual reality art exhibition for visitors, and implemented the native mixed reality application in HoloLens. And the Cyprus University of Technology was responsible to implement the digitizer mobile application for 2D and 3D digitization and rendering. And finally, the Aristotle University of Thessaloniki, LabGeo, was responsible to implement the AR mobile application, realizing the various scenario for outdoor, indoor, and in-home exhibitions. So for each one of these components, I will go through, I have prepared a set of snapshots in this talk, and through these snapshots of the final system, I will explain the main features. A live demonstration will be done tomorrow during the webinar, and in which we will show the virtual reality exhibition creation, the platform, the AR exhibition, and through the various training sessions, we will also show live demonstrations and explain in more detail live the technology. So here the aim is to show you the main outcome and try to explain the features that have been implemented based on the conceptual design provided from PR1. So I will start with the artist-centered content management system. This is a web-based tool, a web-based platform in which is available right now. If anyone would like to access this system, it's accessible through the main CRIMS website, crims-project.eu. And through the POC3, the final version of technologies, you can access it. Anyone can use, can create an account based on an email, and they can start using this technology. To summarize the key features of this main platform, we have mainly two roles, instructors and students, although we have also a third and fourth role, one role for artists, which is a subset of student role. in the sense that we provide tools enabling artists to create their exhibitions, but not in the context of an educational pipeline, educational services. And we also have administrative services, but the main roles are instructors and students. Instructors, when someone creates an account and logs in as an instructor can, first of all, initiate an exhibition for their students. This can be split into a VR, AR, and MR exhibition type. Sorry. Then they can assign their students to the exhibition, and also assign co-advisors. Once this is done, students and co-advisors that have been assigned can also access this exhibition, and through the various tools manage this exhibition from their side. And beyond that, we also have various assessment related services, starting with a regular assessment approach in which an instructor can add a grade and comments to each student based on the outcome of their project, of their exhibition they created. And we have also implemented a complete pipeline based on the curatorial approach, which I will show you in a bit. Beyond that, we also have implemented communication, a chat component, enabling instructors and students to communicate with each other through the platform. Now, from the students' side, students have a set of tools that allow them to manage their digitized artworks, either artworks that have been uploaded from the digitizer mobile app, but we also have management tools in which students can upload 2-dimensional, 3-dimensional artworks in this artwork manager. Tools also beyond artworks are tools that allow students to manage their media, like videos, which can then be entered, uploaded, and assigned into their exhibitions. And from then on, the key components for editing, basically, we have a dedicated workshop editor for virtual reality exhibitions. We have a workshop editor for AR exhibition creations, and a third one for mixed reality exhibitions. And we also, like the instructor's point of view, students can access the curatorial related services, which is basically the whole curatorial component acts as an interface between instructors and students to share and communicate the decisions taken for selecting artworks, grouping them together before students can actually start working on their exhibitions. So based on each of these features, so let me start to show some snapshots, starting with the user authentication. We have implemented a role-based access control system, a classic user authentication component as well, in which a user creates an account first by providing an email, a notification, a verification code is sent to the email. So this follows a state-of-the-art classic approach for user registration and authentication. As I mentioned, this is accessible through the CREAM's website right now. Now I'm viewing a dashboard that an instructor views. So in the main dashboard, instructors can access virtual reality, augmented reality, and mixed reality exhibitions. So these are some sample exhibitions we have created in this account, and instructors can also initiate a new VR, AR, MR exhibition. So initiating one follows the following approach. An instructor provides an exhibition title, uploads a thumbnail, provides various metadata related to the exhibition. Once this is done, the exhibition is created in the database. And what we see here is the stage where an instructor can assign students to the exhibition. So basically deciding which of the students will be assigned and will be able to create their own exhibitions under this exhibition that has been created. And here we also see the communication tools that are accessible so that the instructor can directly chat, send a message to each student. After creating an exhibition, instructors can also manage their exhibitions, edit the existing data, edit the students and co-advisors, as well as access all the assessment-related services for that exhibition. And of course, also be able to delete, if someone wishes to, the whole exhibition and the associated data. Now, from the student's point of view, this is a similar view that the student views, but from including different tools. So again, in the student's dashboard view or exhibitions view, a student can see the VR, AR, MR exhibitions that they have been assigned to by their instructor. So here we see a student that has been assigned to 2 virtual reality exhibitions and 1 mixed reality exhibitions. Now, the difference between the student and the instructor here is that the student can perform various different actions, of course. Access the VR editor, which is a tool set for students, access the curatorial process, as well as other tools like viewing their VR in case this has been enabled, as well as loading an exhibition that they have backed up. So these are some features based on input we received from the previous formative evaluations. We have some additional functionality to enabling students to back up their exhibition, save it on their computer, and load it to keep their own backups and not be dependent only on the system's cloud-based services. Now, I will show each one of the main components, starting with the Artworks Manager. So this is the Artworks Managers for the students. Students can upload, as I mentioned, here we see artworks that have either been uploaded from the Android application, from the digitizer, but we also have a dedicated component enabling a student to upload and manage their 2D and 3D artworks through the Artwork Manager. So in case a student has created a 3D model using a different tool, either this is in GLB, GLTF, or OBJ format, they can upload it in a very easy way and then use it in our platform, so that we are kind of decoupled as well, and not, we didn't want to restrict the student to use only one specific application, but in case the student has their own 3D artworks, they can upload it and manage them. So for 2D artworks, we have one specific stage for uploading a 2D artwork. So a 2D artwork is basically an image supporting PNG, JPEG formats. Student provides a title, uploads the artwork with a specific data type and some metadata, like the year the artwork was created, technique that was used, and so on. And then this is uploaded to the server. For 3D artworks, we follow a very similar approach, but the 3D artwork consists of 2 main stages. The first stage relates to adding the title, a thumbnail for the 3D artwork, the data type that is supported, GLB, GLTF, or OBJ, which are state-of-the-art data types. But here we have a second step as well. Once the first step is done in the 3D artwork, adding the metadata mainly, we go to the second stage in which the student can upload any relevant files to the 3D object. So we didn't want to restrict students here. Basically, in this page, once the 3D model metadata, 3D object metadata have been created in the database, students can upload any relevant files like textures, model, binary information about the model. Everything is uploaded and associated with the main object in the platform. As a next step, we also have, for debugging purposes, basically a simple 3D viewer at the first stage. So what you see here is a 3D viewer based on a 3D model that someone has uploaded. And this Aphrodite sculpture that you see here is a real 3D model created by our colleagues from the Cyprus University of Technology. They provided us the model, we uploaded it with the steps that I've shown you, and this is the result. And it's not for creating exhibition purposes, it's just to test quickly that the files that we have uploaded are correct, and before we can start using it in the exhibition. Beyond the 3D manager, the Artworks Manager, students can also assign associated media to artworks. again, by enabling students to upload other images, videos, any type of data they would like them to associate the data with the artwork. We aim to leverage hypermedia capabilities in the sense that we can now, in the digital world, have an object, digital artifact with associated material connected to that digital artifact. The same sense that, like managing exhibitions, we have also a forum for managing existing artworks in which someone can edit metadata, manage the 3D files, remove them, add new, and manage associated media, delete the artwork, as well as generating a QR code, which is useful for scenarios like the AR application, which has implemented functionality to scan such a QR code to retrieve the digital artwork of this object. Now, we have finished the artwork manager, we have the media manager, similar user interface design. Basically, here students can upload and manage videos. So this is like a content repository, I would say, in the sense that we first upload, manage the media artworks, and then I will show you the main tools for assigning these artworks, the artworks and media uploaded in this library, to assign them in an exhibition. Moving on, this is the main part, I would say. We have the exhibitions manager, in which a student can access the VR editor and the AR and MR editor. I will start with the VR editor, the virtual reality workshop, which is a standalone component with many features, many tools, enabling a student to access the artworks and media they have uploaded and assign them in the main virtual reality exhibition space. So we had several discussions and iterations of this design. As we mentioned, what you see here is an implementation based on Scratch. We have implemented all these features based on open source technologies. Of course, for example, for WebVR, we have based the whole WebVR framework on A-Frame, which is a web virtual reality based component for building VR experiences in a web-based platform. So at the left side, you see the main view of the exhibition. To reach this point, there is another step which we'll show in the demonstration in the next days, in which a student can customize the space in boxes in order to be able to customize and personalize the main space of the virtual reality exhibition. Here we have already created the exhibition, and at the right side, we have all the tools available, enabling the student to, for example, change the room lighting, the wall colors, assign the artworks, assign labels, assign videos, adjust all the artworks like 2D, 3D, move them in the X, Y position, Z position, change the size, change the font sizes, add lighting, spotlights. So several features tools that enable a student to create, customize, personalize their virtual reality exhibition in an easy to use way. So I will go, each of these features are categorized in the main tabs, as you can see here. So we have the room related features, artworks, labels, videos, adjustments. So I will show each one of these in the next slide. So here we see features. When I go to the room tab, I can change the ceiling color, the wall color, the floor color, the ambient lighting, which is the intensity, the light intensity of the whole room, as well as the ambient lighting color. So by changing this, immediately the colors and lighting change at the left side. Artworks, we have here a list of artworks that have been selected in the curatorial process, 2D artworks and 3D artworks. Once the students are assigning these to the exhibition, they are assigned to the specific location in the room. In the same sense, I can add textual labels, textual material to complement the artwork, as well as add videos from my media manager. And once I have added my objects, I can go to the adjustments tab, in which I can change various characteristics about each object. Change the text if this is a label, change the size, rotate it, position it at the Z-axis, change the font color, delete the element, and so on. We have spotlights as well, a dedicated spotlights page, which was added in the second version. We didn't have this in the first version, but based on the input we received from the stakeholders, we implemented functionality enabling students to change the lighting, add spotlights, change the intensity, the angle, the penumbra, rotations, positioning of the spotlights to create their own effects within the exhibition space. And finally, in the last version, we also added a visitor mode for testing purposes, basically enabling students to see and interact with the material as a visitor would do, because one of the main challenges we had from a development point of view was that had to do with interaction design aspects. One thing related to using the tools to create the exhibition, and we also had interaction design aspects in which a visitor would interact with the material as a visitor, not as an editor. So we had to differentiate between these two modes of interaction. Another nice feature that we implemented is the so-called sketchbook. Basically, the idea here is to have a main artwork and associate material around it, like text, images, or videos, so that a visitor can disable these associated material to the main artwork. And this is a sample that we have created in previous versions. As you can see, this is a wall with a sample artwork. Teal Dreams, this artwork was created, and so on. And the other icon on the right side are associated material. And you can also see the spotlights and the lighting that has been created on this specific wall to create the effects. And another view. Some additional management tools. We have backup and loading functionality, enabling students to back up their exhibition, their runtime exhibition, load it, keep track, keep versioning of the exhibitions, even resetting their exhibitions to start from scratch, like as the instructor has created, in case they would like to delete everything. So for doing so, we have extended the main actions. Students can load the exhibition, back it up first, of course, and then load it by uploading the source file, the main source file, which is based on the A-frame-based source code. And they can also delete the exhibition and set everything back to the defaults. This was quite useful for the evaluation studies. In case students were testing and wanted to experiment, they could delete the exhibition and start from scratch and building their exhibitions. Now, what I showed was the VR editor. Now, the VR viewer is basically a component which shows the result of the VR exhibition to a visitor. Here we have a list of exhibitions, real exhibitions that were created by students from our participating partners, the end user organizations. And this is the virtual reality viewer, which is basically a component, the component based on the web-based VR editor, but in full view and with having enabled several functionality for expanding the sketchbook, the associated material, starting and stopping videos, if I have videos, and so on. This is the virtual reality viewer. Moving on, I will show first the AR and MR editors within the platform, and then the main applications which are used by visitors to see the augmented reality and the mixed reality exhibitions. So within the same platform, I can also access the augmented reality and the mixed reality exhibitions. Things are a bit more simple from an editing point of view compared to the VR editor, in the sense that here I upload, basically, I have already uploaded the artworks manager, and then I can assign through this interface the artworks that I would like to be part of the AR or the mixed reality exhibition. So I'm selecting them, and we have also location services functionalities in which we, in case someone would like to create an AR outdoor exhibition, they can select the artworks that they would like to have disseminated within the exhibition, but bound to a specific location. For example, here, if I want to add a latitude, a specific location on Google Maps, I select the artwork, I open the location-based service, I click on the pin where I want the artwork to be bound, and I'm saving the information. Now, this information, the location, longitude, latitude, is then used by the AR application to show the relevant artworks that are in close proximity to the live location of the visitor. So now we are still in the editing mode point of view. Before moving on to the other visitor applications, I will show some further functionality related to the teacher services. Since this is an LTTA event, I think it's quite important to show these services, which is also one of the main innovations, I would say, and contributions to include all these services, curatorial approach under this pipeline of creating exhibitions. So for assessment, basically, instructors can either provide a classic assessment or follow a curatorial process by selecting the open curatorial process. So here I have a list of students, and the curatorial process is as I mentioned, is an interface, communication channel in which the instructor can provide feedback on the selection of artworks made by the students and the reasoning they have behind their selections before students can actually start implementing the exhibition. So it's a step before a student takes before actually starting to work with the exhibition, by getting feedback and information from the instructor to use this as vital input for creating their exhibition. So we have, based on the input we received from the end user organizations, we have split the whole curatorial process in 6 stages. First stage starts by selecting artwork. So the scenario goes as follows. I'm about to start working on building an exhibition, but before I go into the exhibition editing, I select the artworks that I would like to use in the exhibition. Here we see the artworks that have been uploaded by the artworks manager, and I'm selecting specific artworks that the instructor on the other side will see about my intentions, that I'm about to select these artworks and assign them and use them in my exhibition. This is the first step. In the second stage, I can create dynamically create my own groups and assign each of the artworks under a specific group based on color, content, sizing, and formatting. Then provide a description about the arrangements for each of the groups. So I'm selecting the group here, providing a description. Once I save this as a student, this is also accessible from my instructor to see the arrangement I have made, the groupings that I've made, the reasoning behind the grouping and selection. Then the lecturer, the instructor, can provide feedback. So this is the instructor's view. The instructor can see these are the groups, this is the description, the selected artworks within each group, and the lecturer can provide feedback to each of these groups. And the student on the other side can further expand the narrative for the exhibition. Student sees the lecturer's feedback. As I mentioned, this is an interface with 2 views, instructor and student's view. And finally, the student provides information like the exhibition title, the audience, the intended audience, and an overall description about the exhibition, which is also further used as metadata for each of the exhibition a student creates. And in the very last step, so after that, after the previous step, the student proceeds, if the instructor says so, proceeds creating the exhibition. At the final stage, the instructor is providing the final assessment, either by providing free text information or uploading an assessment file with their comments, grading, and so on. and this is bound to the exhibition of each student. This is a snapshot of the communication service. So basically, this is a classic runtime communication service, which enables real-time chat between students and instructors. We can see the chat history, and I'm entering the text that I would like to enter right now, and the instructor sees that at runtime at the other end, and vice versa. Now, this what I've shown you had to do with mainly the Cream's web-based platform, as well as the web VR editor and viewer, and I will show you some information, some key features of the other application, starting with the AR application, which is a different application. It's an Android app, mobile app. We'll then show you the Digitizer app, another application, and the mixed reality application. So the AR application was an application built by our colleagues, our partners from the Aristotle University of Thessaloniki. So the AR app is a smartphone application that enables visitors to interact with the students' artifacts in the context of physical exhibitions, in which an artifact can be augmented now, either in a physical outdoor space. That's why we have shown you the scenario of assigning, pinpointing an artwork to a location on the map. They can also be used within an indoor exhibition by scanning a QR code that I've shown you, or in an in-home exhibition, in which the visitor is enabled to augment any artifact in the viewer's physical space. So this is the first screen in which the visitor can see the artifacts or the gallery that is in close proximity to them, either by gallery or artworks, or see in a quick view the galleries that are near me at that point. And these are some snapshots, various snapshots that implement the outdoor, indoor, and in-home exhibitions. On the left side, you can see a 2D artwork being augmented on my phone by using the camera displaying a two-dimensional artwork. We see a map which shows basically artworks that are either in close proximity to me, near me, so that I can move towards them and see the artwork, either 2D or 3D. We can see a list of artworks in an in-home scenario, as well as at the right side, the fourth screen is an indoor augmentation in which a visitor can scan a QR code, which can be, basically this scenario can be viewed as the combination of physical exhibitions together with a QR code, enabling the visitor to scan the QR code and see the digital version of that specific artwork. And in the latest version, we also have augmentation of three-dimensional artworks. So at the left side, you see the same Aphrodite sculpture that I've shown you in the VR editor. This is also viewed in the AR mobile application. So the same model, the same 3D model is stored in the Artworks Manager in Creams and is displayed in different exhibitions, VR and AR and in MR. And this is another a testing example with another 3D object. With regards to the Creams Digitizer application, we have an Android application implemented. The responsible partner for implementing this is the Cyprus University of Technology. They started building an Android application in the first version, in the first period of the project. We had the team implemented a 2D digitization version, enabling visitors and students to digitize the two-dimensional artwork, paintings, for example, with cropping functionality and storing them in the Creams platform. And the team is currently under development still with regards to the 3D digitization of the 3D artworks. So this is some cropping functionality of the 2D artwork. So basically, I'm taking a snapshot, I can crop the background or any information that I do not want, and then I can upload the 2D version, the cropped version on the CRIMS platform. Moving on, the final application is the native mixed reality application, which is a native HoloLens app implementing the following main features. This is a main dashboard, this snapshot as viewed within the HoloLens device. We have an artworks gallery. We have an artwork extended view and associated media within the gallery. We have implemented functionality that allows a user to match an artwork from the physical world and through image similarity retrieve the digital content of that artwork. We have implemented a cognitive agent, which is basically a scenario and allowing the visitor to make questions using an LLM based engine like ChatGPT. And we have the exhibition viewer. So this is the artworks gallery. Basically what we see here is a list of artworks, 2-dimensional and 3-dimensional artworks as a gallery view. Using hand gestures, the visitor can select the artwork and further view more information. For example, I selected the artwork and I moved on, and I can see the main artwork with any associated media like textual information, a description, a video. And I can also see associated media around the artwork. And all of these media, which are in this example are 2-dimensional artworks, can be moved around by using hand-based gestures. The other component that I mentioned relates to matching a digital artwork with a physical artwork in order to be able to truly follow a mixed reality scenario, in the sense that we mix the physical with the digital world. So a scenario, a relevant scenario here would be having a physical exhibition. Visitors wear the mixed reality device. Once the visitor views the physical artwork, they can take a snapshot of the artwork, and then through image similarity, we retrieve digital content related to the physical artwork. So this is a proof of concept that we implemented in the sense that we take the snapshot through the device, through the HoloLens. Some challenge that we had here related to cropping any background information and noise. And once this is cropped, we respond with the top 3 similar images from the database. And once the user selects the image, the digital version and any associated media is shown in the HoloLens device. Cognitive agent, another very nice work that was implemented here. And this is also, this component also received an award at the ACM User Modeling Adaptation Personalization Conference. As Professor Kogopoulos mentioned earlier, we have received the Best Demo Award last year at this event, which is a well-known and accredited event in the personalization research community. So basically, what was the main aim of this research attempt? Basically, we created a dedicated component in which artworks were shown in the mixed reality device, and visitors could make questions, make queries by narrating, by telling the question. The question was recorded, and then by using an LLM, specifically ChatGPT API, ChatGPT responded with the answer, and the answer was shown to the screen to provide runtime information about each of the artworks, enable basically the visitor to make runtime questions about the artwork. And the attempt here was to investigate the feasibility of such approaches, user experience, trustworthiness of the answers with end users within this context. As I mentioned, the Best Demo Award at this conference. And finally, we have exhibitions created at the created at the CRIMS platform site. And here we have a list of exhibitions, and once I select an exhibition, the assigned artworks, either 2D or 3D, are listed. I select the artwork. I can further view the associated material, 2-dimensional and 3-dimensional. As you can see here, these are all images and 3D models, 2D and 3-dimensional models as uploaded in the CRIMS platform, and viewers can take these artworks and move them around, may resize them, change the rotation, and so on within the mixed reality context. Yes, thank you for your attention. As I mentioned, the live demonstration of this will be shown in the next days. I wanted to show you all the main features of the various components. I would be happy to answer any questions about our technologies.
Thank you, Mario. Gave us a tools.
Sorry, I cannot hear you well. I don't know if it's on me.
Yes, yes. Thank you for the fantastic presentation. You gave us a holistic view of all the work that has been done according to the development of this project. Is there any question for Marius? Hopefully, the next days we will have the opportunity to see more about all these features. And also, I'd like to mention the multiplier event at the end of January, where we will have Marius in person in the University of Patras and interact with him about all these fantastic tools.
Thank you.
Is there any question? Okay, then we can proceed to the next topic. Panagiotis, you have the floor.
Thank you very much. The next topic is about project result 3. Is the valuation specific aspect of the CRIMS project. So this has to do with assessment of applications that are or were under development. I hope you all can see the slide titled Overview of Project Result 3 Presentation. So the role of Project Result 3 is basically to provide feedback and input from stakeholders, mainly art students and art teachers.
We see the PowerPoint application.
Sorry?
Yes, we don't see the view, the presentation view of the PowerPoint.
Okay. Let's make sure that. Should be okay now. So I guess you can. Okay. The importance of art students' feedback and participation is key. That holds for all stakeholders. And we're going to see an overview of the methods employed, because there is a methodological interest. There has been a lot of research and discussion about how do you assess such extended reality applications. And obviously, we're going to have a look on key results and findings. As mentioned earlier, Project Result 3 is something that can be described as a tripartite aspect of the project. It has 3 tasks. The first is to plan and design the evaluation methodology. The second task was to perform the formative evaluation cycles, the first and the second. And the final summative evaluation, which is being concluded as we speak, is the task 3.3. Now, the 3 phases of the evaluation, as I mentioned, is to create the actual framework of the methodology. This was a fairly complicated task. We will see later on the actual methodological approach that we have taken, then employ the methodologies created, firstly in the formative evaluation study, first and second, and a third evaluation cycle, which is the final one. Now, I have to reiterate that the CRIMS digital tools were highly influenced and informed by the feedback received from all stakeholders, mainly art students, through focus group discussions and questionnaire responses. So we had two major pillars in terms of the assessment methodology: open-ended discussions with groups of 7 to 12 people. Sometimes we had informal focus groups during lessons with larger groups of students, and online questionnaires in which, for the most part, students were kindly asked to tick predefined answers, mainly on a scale of 1 to 5. So the applications were shaped in accordance to the needs and priorities as they transpired through these evaluation phases. And we employed the philosophy that participation of stakeholders is key, because these applications are created for them, so their voices have to be heard and taken into consideration. Now, the summative evaluation phase is a phase that includes larger number of participants. This is pretty much an outline that gives you a scale of the people who were involved. We have to work with 4 separate stakeholder groups: art students, art lecturers, visitors, and ICT specialists. And that holds for the 4 main separate applications: the AR, MR, VR, and the digitizer. In the specific table, the AR outdoors stands for AR, and the AR indoors basically describes the mixed reality app. As I mentioned earlier, we have 2 main avenues to gain insights in how stakeholders think about the ongoing development phases of the applications at hand: online questionnaires and focus group discussions. Now, going into a closer look on the questionnaires, we actually have 3 main approaches. We integrated the system usability scale. That's a fairly standard 10 question template and straightforward questionnaire that is widely used in evaluations that try to capture the efficiency in terms of usability, as the name suggests. Then we have a fairly large number of questions which are specifically adapted for CRIMS. These questionnaires come on types of questionnaires which in turn relate to extended reality experiences. There are many different approaches on how you build a questionnaire to capture the sense of presence and other, if you like, extended reality specific aspects of user experience. So we sort of used them and manipulated them a little bit to adapt to the special characteristics of art exhibition applications. And we, from the second phase onwards, we used the user experience questionnaire. This is a very interesting tool developed in Germany by researchers. Now, this is just a quick look on how these Likert scales look like. Stakeholders are kindly asked to tick on a scale of 1 to 5 which answer is better describes their thoughts. This is obviously this is not something that you are expected to read, but just to give you a sense of if you like, the sets of questions. Now, this is an SQS questionnaire, 10 items. Some examples of adaptive questionnaires. Did the creation of the exhibition encourage self-reflection on your own creative process? This is, if you like, more art exhibition specific approaches. Now, this is the user experience questionnaire I mentioned earlier. Again, this is a 7-point scale. People are encouraged to tick the number they feel it's closer to how they feel about the overall resonance of the application use to them. The interesting thing with UEQ is that it sort of differentiates between pragmatic qualities such as efficiency, dependability, intuitiveness. Perspicuity has to do with the ability of a system to be easily understood, and the so-called hedonic qualities that have to do with the sense that this is innovative, this is groundbreaking, this is stimulating, this is interesting, this is pleasing. And when it comes to art, because things have to be, if you like, affective, they should be stimulating, otherwise it's not going to work. We thought this is a very good tool. On top of that, ingrained in this questionnaire style is the fact that once you get your data, it has an embedded feature that allows you to analyze, and on the basis of some pre-existing benchmarks that are you are able to manipulate, if you like, to an extent, you can situate your answers into a scale, bearing in mind that this scale is created from responses that have to do with finished industrial polished applications. So it is understandable that when you assess an ongoing under development set of applications, the results you're going to get might not be well into the deep green area, as it were, which indicates the highest levels of acceptance. Now, the main points of interest in relation to where we focused on is we tried to understand how things are going in terms of usability, the intuitiveness, how understandable is the system, how user-friendly, how it supports users to understand what they are expected to do, and so forth. User manuals have something to do with that as well. System integrity, dependability, basically. Of course, we are interested in getting some feedback in terms of how adequate the system is for exhibiting artistic material. So this is an art specialist perspective sort of thing. And we are looking into the educational potential, if you like, the ability of the system to support learning of art students, especially in relation to curatorial issues. So in a nutshell, the main conclusions that we gathered in relation to possible future directions as the phases were going on is that we should enhance our platforms and applications on 4 different levels. These have been taken into account and integrated to a great extent. Realism and aesthetics, ability to manipulate space, the visual efficacy, if you like, of this whole set of tools was a key issue for responders. Usability kept cropping up as an issue. Art students would like to be more, if you like, supported. This is an issue that comes up on the in the 4th bullet point, which is guidance. People felt they needed more if you like, error messages, prompts, things that could sort of help them navigate through different menus, possibility, and so forth. Sometimes there was some confusion. So we again and again changed tabs, changed semantics, improved, if you like, the structure of the path users are expected to take. And another issue is contextualization, which has to do with the ability of users to add context through visuals, texts, multimodal material around their exhibited artworks. This is a very strong point. This is something that you can easily get in a digital, or if you like, an extended reality environment, but not in a physical environment where you can only add context to an artwork because of physical constraints with additional text, a little paragraph or something like that, or a title. Whereas in the applications we are creating, we, as you saw through the excellent, the fantastic presentation of Marios, art students are able to add additional material, visuals, videos, even sound, as associated resources that are linked to an artwork which is exhibited. And I have to say that the students were quite positive about that. So, as mentioned earlier, there was a recurring theme. People wanted to be able to manipulate virtual spaces as much as possible. Even in the summative evaluation phase, some people would nag, okay, why not having curved walls? Or the 5x5x5 module, we have a module that is basically built upon the idea of having 5x5 cubes. Some people would like to have the ability to go for diagonals or kind of more fine-tuned possibilities. Nevertheless, this is something that I think would crop up ad infinitum. This, if you like, edge to be able to make the most out of the virtuality of a space that is manageable and malleable. I'm not going to reiterate the another key finding, which had to do with the need for guidance and the will to add context. Now, in terms of suggested improvements, there has been some discussion and some, if you like, positive outlook in terms of being able to integrate the social aspect, some sort of embedded ability to have a synchronous or asynchronous communication amongst visitor stakeholders. Obviously, this is something that already is a key factor as art lecturers and their students are provided with a platform in which they can discuss through text, curatorial or other issues. There were some suggestions that perhaps our students should be able to have multiple versions of the same exhibition stored. And these are some snapshots from the first evaluation cycle. Now, as we move towards the second and the summative evaluation, you can see a little bit again how people can add context, simple texts here. Just to give you an idea of what we created during the tests and the specifically created exhibitions that were subject to evaluation from visitors. So this is a simple layout. The interesting bit is that once you click on the artwork, this paragraph on the left appears. So you have an element of interactivity here. So something that could be intrusive, perhaps, is not present by default, but once you click on it, it sort of appears. Another example from the student perspective, from the student end of things. This is a simple label with an artwork, and in the so-called visitor mode, there is a specific tab in which art students are able to see what the visitors of their exhibition would see and test the interaction aspect of their exhibition. So in this instance, in this case, once somebody clicks on the main artwork, another sketch, another drawing appears. It could be, if you like, another sketch or something that provided influence or inspiration. And of course, there is additionally the ability to interactively make other texts appear. So once you click on the main artwork, you are able to see more things. So these were, if you like, testing grounds to get assessments. We used galleries from Shankar students, very elaborate exhibition that was used by visitors to assess what is going on and what they think. Some creations from art students, and these are some actual results from the second formative evaluation. We're finalizing the summative charts, if you like. It has to be stated that the results are pretty similar. We have the data and we're still working on the final touches. Now you can feel that is probably in a sort of in-between area, which is understandable because this is not like a commercial application, and users or visitors are having some sort of not limited, but I would say in some cases, they even have zero experience as users of extended reality apps. So this had to be factored in. And last but not least, what we have gathered is that art students, being creative people themselves, feel strongly that they should use extended reality tools in a creative way, not just as a passive way to present something that pre-exists. It's not some sort of using digital tools as an interesting way to structure and communicate a portfolio of their work, but they felt that they wanted to explore and, if you like, try out virtually all the possibilities, all the potential that is provided by such tools in ways that are creative themselves, manipulate spaces, make things that are not possible in the physical world. And that resonates with something that a key theorist who is working on research methodologies related to culture-specific extended reality technologies, Gifreo Castells, if my pronunciation is right, who said that the challenge to exploit the medium's expressive capacity is key factor that should be given attention. That's in the approach to the curatorship of virtual reality exhibitions. And this was, if you like, a compass that is, if you like, a key theme that we tried to communicate with the students, and that's some sort of the feedback we received from our students as they would like to explore and, if you like, make the most out of XR technology as a creative medium, and not only a medium through which they show creative practice. And this would be it. Just to reiterate that some challenges that had to do mostly with need to navigate through tabs and through, if you like, the menus. Some students felt that could be more intuitive and so forth. But then again, I think this is within the brackets of what is to be expected, given that responders would have to familiarize themselves both with technologies that many were first comers in XR apps, and as is the case with any platform that has a complicated, if you like, layout, people would have to familiarize themselves with the process itself. So in a nutshell, I think that the results are fairly encouraging, and moreover, we have received qualitative feedback because we have 3 open questions in which stakeholders are encouraged to provide specific commentary, through which we sort of gained many insights, and we cherry-picked some of their inputs, employing it into the process of developing and optimizing the applications that Marios so aptly have just presented to you. Thank you.
Thank you, Panagiotis, for the excellent presentation. Is there any question? Okay, then I think that we can proceed to our coffee break till 6 o'clock and come back for the next 2 presentations. Thank you very much.
Hello.
Hello.
One second. Okay, Dimitri, I'm sharing my screen.
Yes,
full
it's
screen.
okay, Rebecca.
Okay,
It's okay.
great. Thank you. Good evening, everyone. My name is Rebecca Vital from Shenkar in Israel. We have been the partners responsible for the Intellectual Output 5, which is the webinars for training the trainers on virtual exhibitions for art students. To break down our project result overview, here we have already done 5 webinars. 2 were aimed towards art or design students. 2 were geared towards faculty, lecturers, and instructors. And 1 was geared towards IT engineers, a more technical webinar. There is 1 more webinar to be hosted within this LTTA, which is tomorrow at 4 o'clock. And this will be a webinar that's open to the broad public. We are presenting here the final results for our platform. It's a hands-on live demonstration of the VR platform, of the AR app, and also of the mixed reality features that we have developed. Webinars 1, 2, 3, and 4 were solely taught by the lecturers at Shenkar, by myself, by Shoval Nir, and by Galit Gaon. Webinar number 5 was taught by Shenkar and Cognitive UX. mainly by cognitive UX. We gave the introduction, and cognitive UX came to give a live demonstration and the more technical aspects of building the platforms. And in webinar number 6, we have planned that we will teach part of it, Shankar, with Shoval Nir doing the live demonstration of the VR platform. And then Aristotelio University is presenting the AR app, and Cognitive UX will present the mixed reality. The webinar recordings are published on the CREAM Moodle page, which is also hosted in Shankar's Moodle. It's open, no need to log in. We have a link here on the screen, and the link is also from the CREAM's website with all the material that, with all the additional training material that we have on our Moodle. I'm going to show you in a few minutes. All webinars have been transcribed and they'll be included to our report of the project. And all the recordings of the webinars have been uploaded on the CREAM's cloud, and they are available also on our Moodle. So here is the breakdown of the webinars that we did. In May 2023, we did a webinar for the lecturers and another webinar for the students. These webinars, they were more focused on conceptual aspects of curating a VR and AR exhibition. Also, we talked about using VR and AR exhibitions as an educational tool and also as a tool for art representation. At these 2 webinars, we did a live demonstration of POC 1. Then in May 2024, we did again 2 webinars, one for the lecturers and one for the students. Here we did a demonstration for POC 2, which was much more developed. So most of our focus was on the hands-on practice of how to create a VR exhibition, both from the perspective of the student as a student user, as well as the perspective of a lecturer that wants to open a course and wants to give assignments to their students. In November 2024, we did the webinar for the software engineers. Cognitive UX did a live demonstration of the features, the latest features of the platform, and they showed the back end and how one can modify the CREAM's platform and customize it for each educational institution's needs. Tomorrow is the final presentation, and as I mentioned, we will do a live demonstration of the VR, the AR, and the MR platform. Below you can see our Gantt chart with the aims for our milestones, and we actually exactly met the dates where the milestones were presented, except this last webinar that is coming a month later than it was planned. It was planned for December, but we decided to combine it with the LTTA. So we are giving it in January. Going backwards, I want to show you a little information on the registration and participation for the webinars. For webinar 5, which was the last webinar, we had 16 registered participants. we can see here the distribution per country, 37% from Greece, 37% from Cyprus, and then the rest of the participation was equally distributed between Germany, Israel, Norway, and France. Specifically, when we look at the academic institutions that participated, 43% of the participation were other institutions, not the partner institutions. 18% was from the University of Patras, 25% from Aristotle University, and then we had a smaller participation from Shenkar and from NUTU. The larger amount of participants were students, but we also had some instructors, some PhD candidates, and some researchers. For each webinar, we have an attendance list of everybody who connected and participated within the Zoom section. So we also have documentation of the actual participants. This is webinar 3 and 4, the webinar on POC2, both for the lectures and for the students. We see a large participation here from Greece and a large participation from the United Kingdom. Some other countries also registered to participate. If we look at the distribution here, we have 42% from Aristotle University and 41% from Shenkar. And then we have some 10% of other colleges, a small percentage also from the University of Patras in these two webinars. And this is for webinar number 1 and number 2. Actually, this was the beginning of the project. We had the most participation. I think all partners did great efforts to bring a lot of participants. We have 53% here participation from Shenkar, 27% from Aristotle, and then a smaller participation from the Norwegian University, University of Patras, and some other universities outside of our partner network. The larger amount of participants were students, as was expected also, and we had a smaller amount in the instructor webinar. And we had also some research fellows, a UNESCO chair, PhD candidates, and some other special teaching staff. So here are the 5 webinars so far and the amount of actual participants within the webinars. And as I mentioned, all of the webinar recordings, as well as all the training material, can be accessed from our Moodle. The Moodle can be accessed on the CREAMS website. We can see here in the knowledge repository, we have the third option is the CREAMS Moodle, which leads directly into our Moodle. So let's take a look on what we have inside our Moodle. We have a link to the project website. We have a link to POC3. At certain points of the project, we had also a link to POC2 and to POC1, which are not active anymore, so we took those down. And then we have the webinar descriptions. We have the description in 5 languages, the course description, which is in Greek, in English, in Hebrew, in Norwegian, and in German. And that were created with the help of all the partners which participated here. We have links to the questionnaires that Aristotelio University created. And these are links that whenever we had a webinar or an activity, we asked our participants to go to the links and fill in the information. Then we have some user manuals. We have a main user manual, which has been translated in all 5 languages. We have a user manual for the digitizer. And in addition, we have some additional training material that shows the course modules and what the course modules of training on the platform should entail. And we have video tutorials, short video tutorials for entering the platform as a student, for entering the platform as an instructor, and all the steps and all the possibilities that, that are there. We have a video manual, a video tutorial for the mobile app and for the digitizer. In addition, we have the recordings of all the 5 webinars here. And I would like to go a little bit to additional contributions that Shankar did to this project, that was beyond our intellectual output, number 5. We participated in defining the curatorial process. We have a department for curatorial studies in Shankar, and then we sat and we broke down the process so that we can develop something to accommodate it within the app. We created a digital twin for a Shankar art gallery that we have here. We gave all the dimensions and all the information to Cognitive UX, which made this gallery that we have in Shankar as one of the options for galleries within the platform. This was great because our students could go and set up an exhibition before they actually going to build the exhibition in physical space, and it created a space where they can experiment with different options regarding the curation of the exhibition itself, and then narrow it down to one version that they would actually build in physical space. We participated in all the technical, in several technical meetings to give feedback and contributions to the other project results. And we have translated the learning manuals to Hebrew. We initiated and participated in the writing of some academic papers, and we incorporated the CREAMS platform in several courses of our curatorial studies and in exhibition design courses. We have organized a training summer workshops, which was focused on the CREAM platform last summer, and we merged it actually at the end with the LTTA activity of CREAMS in Cyprus. And Shankar has allocated additional budgets for the CREAM projects to supplement the European funding, both for travel and for equipment, for goggles, VR goggles that we used within the workshop, as well as in the beginning of the project to test the platform within the VR goggles. This was the breakdown of the curatorial process that myself and Galit Gaon, who is a curator, many years curator, and also is the director of the curatorial studies in Shankar, created. And based on this matrix, on the steps that you see on this matrix, we based this to create the back and forth between lecturer and student within the platform to understand the curatorial process and the thinking behind it. We find that the additional value of the CREAMS platform is not just putting up art on the walls of the galleries, but actually thinking of what's the narrative, what's the story I want to tell, and how do I tell the story, and only then going and setting up the virtual exhibition, as it also happens actually in real life in physical exhibitions. So the steps, the stages that we go through it is gathering the artworks, is acquaintance and examination of the artworks, editing and writing about the artworks. There is a stopping point here for presentation and reflection and getting feedback from the lecturer who is here to help them during the process. Then there is the process of editing the order of the artworks, depending on what narrative we want to present within the exhibition, processing from an idea to a concrete text, transit from text to space, and then we go into the VR space and we are actually starting to position the artworks. At the end, we have the scenography, which is the final positioning of the artworks, and then the actual placement on the wall, whether it's height or texts that go and accommodate each art piece. And of course, the process of feedback, which is integral in any course, that the lecturer needs to give the feedback to the student and evaluate their work. When it comes to academic papers, I myself initiated this academic paper that you see in front of you. It's called Comparison of Extended Reality Platforms and Tools for Viewing Art and Exhibiting Art. It looks at around 20 different platforms and VR or AR tools that relate to digital exhibitions and makes a comparison on the pros and cons of each platform. This also helped us in Shankar to understand what's our additional value in our platform that we want to bring in. The paper was published in Digital Applications in Archaeology and Cultural Heritage, a journal from Elsevier. I also participated in a paper initiated by Dr. Stella Sileu, From Physical to Virtual Art Exhibition and Beyond, Survey and Some Issues for Consideration for the Metaverse. And I participated in some of the writing for the paper that was presented in the International Conference on Information Intelligence Systems and Application. The paper was called Personalization Surfaces in Art Education Environments, First Survey Results, and it was also published in the conference proceedings. Here I want to show you our gallery in Shankar. This is the gallery that we use as a case study space with the help of Cognitive UX. We modeled this gallery and placed it inside as an option inside the platform. And as we integrated in many of our courses, curatorial courses, the CREEPS platforms, many of our students worked actually in the gallery in virtual space while also working in it in physical space. Here you can see on the left the actual gallery, the physical gallery, and on the right the VR representation, the gallery in virtual space. And I want to share with you my experience about organizing a workshop. I think that this was the most efficient and intense way to expose students to our CREAMS platform and to the project. The course was developed by myself with the participation of Galit Gaon. Shoval Nir also joined us to give some hands-on training within the workshop. We took a group of 7 students, and for 4 days we worked intensively from 9 o'clock in the morning until 5 o'clock in the afternoon. Within this workshop, the students got an introduction to the CREAMS project and a representation. We talked about exhibitions and collections. It was an open introduction to the concept of curating and collections in general. Then we talked about how do we collect material to create an art exhibition, and how do we organize the material. In this case, the students worked on their design portfolio, but in a VR exhibition space. Then we talked about what's a design portfolio, what it should entail, and the students started working hands-on on classifying their material and creating a narrative. We used the CREAMS platform to go back and forth between their narratives and their classifications and their texts until everybody got personal feedback and finalized the narrative that they're showing inside the space about editing and categorizing the material. Then the students received a lecture on what it means to go, what's the difference when we go from real to virtual? What are the opportunities in virtual space? They had a hands-on session on the VR platform again on how to place, do the actual placement in VR space. And they worked for another 2 days on their projects. And I want to show you the results from this workshop. The results were presented within the LTTA meeting in Cyprus, where Kat hosted us. You can see our students while they're working here in Shinkar on their projects within the CREAMS platform, and they're presenting their projects at the end of the 4 days to a panel of lecturers that deal both with design, interactive design, and curatorial studies. And we can take here a peek inside their galleries. We can see that they even managed to create illusions of depth with putting images in space. This is POC2, so we had the opportunity to upload into the platform 3-dimensional elements. So you can see partitions within the spaces. You can see architectural elements that they designed, and they were part of the project. Here you see the element within space, and then you can see a rendering of the same element on the wall. And we can see intricate spaces already created and additional partitions helping to add to the modularity and to the spatial design of the gallery. And the students used everything, used the lighting, used the opportunity to put running media, video media, and 3-dimensional objects. And here you see our students being hosted in Cyprus and participating and presenting their results in the LTTA. Thank you very much for your attention.
Thank you very much, Rebecca, for your fantastic presentation. You showed everybody the potential of our framework, I think, what things they can do with it. And it was very interesting, at least for me. Is there any question for Rebecca? Okay, then I think that we can conclude the first day of our event. Wrapping it up, I can say that we presented briefly the whole project and the most important outcomes of all the project results concerning our project. I think that it was very interesting, and we gave, let's say, a deep view inside the work that has been done within this project. I hope to see you all tomorrow at 10 o'clock for the second day. That's all for me. Thank you very much.
Thank you. Bye-bye.
Thank
you.
you. Bye-bye.
Bye bye.